So, hello, I am Mairo Rufus, and my accent is not that good. So, if you have any issues, you can stop me at any moment. I will repeat. So, welcome to this talk about improving SNBCmp, the capture GIF tool. I work on this part of my Google Summer of Code 2019, and my mentor was Aurélien Aptel. Okay. Who I am. I'm a final year master in computer science student at Polytechnic Yaounde in Cameroon. And there are some of my social handles, GitHub and Mastodon. This talk is about an existing tool, yes, which has many links across the internet, which was presented at the SambaXP 2018. You have the links. SDC 2019 and LCA 2020, and you can obviously view the repository on GitHub. So I will talk about what is the JSOC briefly, just explaining for those who don't know what is SNBCmp. We'll briefly come back, and then I will take on my advanced and my what I worked on during the summer of code, which is choosing another output of Tshark, a GUI for SNBCmp, and porting it to other platforms. First, networking problems are hard to debug. If you watch talks about SNBCmp, the story, you will see that it's not that easy to actually spot where the bug is when a bug in Samba is reported. It can be in the client, it can be the server, it can be the network, it can be in the kernel, because Samba has a kernel module called CIFS, CIFS. Okay. Okay. No, so what is the JSOC? The JSOC is a global program for 18 years old student, 18 years plus years old student, and each student works on an open source project for an organization. And the organization assign a mentor to each student, at least one mentor, because some students can have more than one mentor in case of problem of availability. And the program lasts for 3 months. So the coding part of the program lasts from June to August. You can find more at the official page of Summer of Code, which is summerofcode.google.com. Okay. What is SNBCmp? SNBCmp is a network capture GIF tool for SMB, which has some interesting features like support for encrypted SMB packets. It uses Tshark in the background, Tshark, the Wireshark clay, and it operates in 2 modes. Single trace, where you only load one pcap file, and GIF trace, where you load two traces side by side, and you have the GIF in the bottom, like you can see in the slide, the little screenshot at the right. Okay. First of all, the previous version of SNBCmp used the Tshark test output, which you can view briefly with Tshark with the -v parameter, and that is what it looks like. Okay, and that is what the Tshark's pdml, which you can access with -t pdml, looks like. Basically, you have a top level tag, which is pdml. Then you have the packet tag, which denotes a packet, and inside the packet tag you have the proto tags, which denotes the protocols. In the proto tags, you have then the field tags, which can contain other field tags, which are the component of the protocols. And finally, we have the Tshark JSON output. You can access with that JSON parameter. And it's just a bunch of nested objects. So the packets is an object, and each protocol of the packets are objects, and each element of the protocol are objects in nested. You can have many nested level like that. So this is it. Now we had a choice to use another output, but why do we want to use another output? First, we want to make better and more precise diffs, because if you look at the text output, it's just a bunch of strings, and you can really operate semantically on those strings. For example, if I want to diff to text line, if only one letter change, the algorithm will just see that everything has changed. So it's a new line which is inserted. And that's what's not that great. And we have the possibility to add ignore rows. While parsing the text output, there wasn't really a way to know that this node is about I don't know, cryptographical. It's about an cryptographical algorithm, or I don't know. It's just something like you have the text and you diff it with another text and you see what will come out. So using another output like JSON and PGM or pdml, we can have a better sense of that. And speaking about more detailed output, with the text output, there are some elements that are missing. Like for example, you can't really know in the text output what is the cryptographical algorithm used, while it's an example of detail which is present, for example, in the pdml output. Okay, there is a compiled pros cons table for those new formats, and spoiler alert, we ended up choosing pdml. The pros are it's XML based, and XML is a well-established format since a couple of years. The standard library of Python has a C implementation of a library for parsing XML, which is very good because it's fast. And the fields of the pdml are human readable with the show name attribute. Every attribute, every field in the SMB has the attribute show name, which is human readable. There is one con I could find. One con, it's that there are many irrelevant information like post and size, which is basically the I didn't look further, but it's the position. It's probably the indentation level. Okay. The JSON on the other side has some pros. No irrelevant information. In the JSON, everything is usable and used, and it's easier to parse because you don't really go out of the boundaries of Python because it's built in. The JIT is built in. Some cons: no summary lines, so you can't use JSON to navigate in the file. You have to use another output. And some fields are non-human readable. For example, if you take the SMB.negotiate context hash algorithm, instead of showing you an algorithm, it shows a hexadecimal value, which match certainly an algorithm, but for a human, it's not that practical. And the last issue, which is not really an issue anymore with recent version of Pythons, is that dictionary entries are not ordered. So when you load a JSON file, you can end up having a too much overhead just to keep the order in place. Okay. First try. So while which we ended up choosing pdml, like I said, now we had to address the diffing of the pdml. The first try was to look for an existing library, xml-diff, which happens to also be a command line utility to diff XML files. And there is a good article from Stanford. The tool is based on change detection in hierarchical structured information. You can have the paper at the link. It offers an API, a very good API to use XML-diff as a Python library, and you can choose many parameters to tune up the matching, the ratio mode, how accurately the similarities are computed. The more it's it's proportional to the speed, to the time it takes to process the information. And you have the fast match, which find a chain of matching nodes. That means that the problem with XML-diff, I won't say the problem, it's the way it works, is that it takes one node and it compares it to all the other nodes. So you take the first node, go for every other node in the second XML tree. And with the fast match, you are more able to find a chain. So instead of taking one node and comparing to each node on the other side, you take a chain of nodes and try to find in another chain which matches the first one. And the formatter, which is the presentation of the results, you can present the results as another XML file, you can present the results as a text file, something like that. That's what it's inside the formatter. Then we faced some difficulties, and the first difficulties was that without fast match, it was too slow, way too slow to be usable in a real world scenario. And with fast match, it wasn't really accurate. I will come back to it later. And there was too much noise because if you use fast match or if you don't use fast match, there are some differences that are highlighted that are not really relevant for our use case. And finally, the pdml structure wasn't suited to XML-diff because the pdml, the core information for the pdml are the attributes inside the field tag. And an XML-diff is more suited to compare the nodes directly instead of the attributes. So if, for example, I have a tag field and the attribute, I don't know, SMB2, and you have another tag at the same level in another file, which is field with SMB3, XML-diff will highlight that as a node removed, and you remove the node and you had another node with SMB3, even though it's just one character that changed. All that makes XML-diff not reliable to compute pdml diffs on the fly. So we had to come up with our own implementation, which is based on DFS, depth first search. And it came from a couple of realizations. We can take advantage of the structure of a SMB packet. On this same page, there is the SMB2 specification, which is quite long, but you can have a look. And this specification details many things. So the pdml of SNB packet, it's not really just another XML files. It obeys certain rules, and you can take advantage of that if we implement our own thing. And we can use ranging from that. We can use a simple heuristic. It's the comment file of the SNB header. When you take the SNB header, there is a comment file, the comment field. The comment field, if the two SNB header have the same comment file field, you doesn't have the same comment field, it doesn't really make sense to compare the two, because the two are two fundamentally different packets. And in the detail of our implementation, if we stumble off a non-flat node, we just reuse difflib in this case when the comment field is different. And by coming up with our own implementation, we had the possibility to expand with ignore rules. Like in a pdml file, I know that I will never use the signature because it's automatically generated by the system, by the client, the SMB client. I can say that ignore signature to avoid too much noise in my comparisons. Okay. Then we had to come up with a GUI. Why a GUI? A GUI because we have more control on the GIF presentations by using pop-ups, by using rich text, which is not really possible in the terminal, like previously with SNBCmp. And most of the Python GUI toolkits are multi-platform. It means that you don't have to really write a specific code for that. It's already present. And to make it accessible for a wider audience, because because people were always reluctant to use SNBCmp because it's a command line tool. I had to recommend it, but okay. Now a comparison of some libraries that I found interesting for developing the GUI of SNBCmp. We ended up choosing WX Python, which is now labeled as Phoenix, because it had a good documentation, had a WYSIWYG, and it was native by default. So I didn't have to add some overhead boilerplate code to have native widgets. Okay. And it looks good, because if anyone in here had used takinter doesn't look good. Okay. And the same on Windows, basically. It's not that too different. Okay. Supported platforms, Linux. On Linux, we have a couple of advantages. It works out of the box. You don't really have to install anything else if you grab the binary. And Wireshark CLI needs to be installed. It's a dependency, but if you are analyzing packets, you already have it. And there are some optional dependencies we used to make the SNBCmp. First, LXML, which is faster than C elementary for our use cases. You can have a look at the benchmark of LXML. It's very interesting. And for our use cases, it was basically faster than the standard library implementation in CPython. And because we wanted to make SNBCmp as much as standalone as possible without overhead for the user, we decided to make it as an optional dependency, and obviously WX Python for the GUI. During this project, I also fiddled a bit with the packaging for RPM-based distributions, and it was really difficult. I ended up writing a spec file for OpenSUSE only, because each RPM-based distribution I come up with, I faced, had different guidelines for writing the spec files, and it was mainly a two manual work to begin with. And if the platform you are targeting doesn't really have a dependency package, you have to package it for yourself. So it's a repetition of work. So all these make the packaging very tedious, at least for me. On Windows, which was the main target I recall, the GUI works out of the box, so you just need the usual Tshark, because the SNBCmp is based on Tshark. And if you want to install the CLI, you need some tweaking. But with WSL, you don't really have to suffer anymore, because yeah, it's basically a Linux kernel. Just install Tshark and you are good to go. But before WSL, we had to port somehow the CLI to Windows, and we did a couple of interesting tricks. You can see that. The first thing was to bundle a Wireshark build, stripping useless things. So we grabbed a Wireshark build from the website, a portable version, and we downloaded a Python build, the Python embeddable build also, the zip file, and we ended up writing a C program which launches the interpreter with the correct arguments to start SNBCmp. It was a self-contained archive, and you can find the result on the releases of SNBCmp. It looks like that. Very cool. macOS theoretically must be supported, but because we didn't have a Mac, we don't test in. Okay. In retrospective, GSOC was a really good experience. I started to be familiar with the image-based open source development, and my mentor was great and always available. I had a couple of blogs, and he was always there to point me in the right direction. And the imposter syndrome. At first, I was like, "Wow, I can't do this," but finally, it turned out great. Okay. I prepared a little demo of SNBCmp GUI for those here. So I'm not sure. Okay. File manager. SNBCmp. Okay. The GUI. Okay. The GUI. So I open the first capture. Trace. Okay. The first, like you can see that the first capture is loaded in the first panel. Now I open the second capture. Okay. It basically acts like SNBCmp, but for the GUI. You can browse, then you can see the differences. Here it uses the same algorithm as the first version of SNBCmp because it's faster. You can browse each, you can go down individually in each panel. You can do that for the same. You can use the mouse, of course, if that one's good to you. Okay. Now we synchronize, and you can search through the packets, and you just need a partial match. So if I put it weak, I can find all the packets, and it's a circular search. So when it reaches bottom, it start again. There are a couple of options, like choosing another engine, the pdml engine that we developed during the sum of code. When you start another diffs, it basically changes, and there is what happens. You can see that with the new engine, it doesn't appear now. If if field is modified, it doesn't appear like a uh, two different lines. The engine clearly state that the file nt status is just modified to status success, and you can even permute the two captures if you are more comfortable watching it from this side. Okay. And the last feature, because why not, it's changing the color. So okay, just select this. I can select this, I know, and the color changes because it can be cool. Okay. Now the follow-up. There is another utility developed by my mentor. It is currently a work in progress. It's the generalization of the SNBCmp concept. So side by side diffing to every protocol. So doesn't to make it work not only with SMB. Thanks for listening.